Welcome to the video on distribution. If you're looking for more complicated problems, such as something like this, or even fractions, or even something like a binomial times a binomial, I will cover these later in the video, so you can feel free to fast forward. For now, let's start off with something relatively simple. First, you want to ask yourself, can we apply the distributive property here? Meaning, are we working with expressions? Is at least one of them in parentheses? And are we being asked to multiply? You can see here that the -3 is bumped up against the parentheses, so that means we're being asked to multiply. And this expression meets all of the requirements for distribution. So let's go ahead and distribute. In order to remember which terms I've distributed, I like to draw arrows and then do the math after each arrow. This way I know that I haven't forgotten anything. It's not too hard to remember in these more simple problems, but it can be easy to forget what you've distributed in larger problems. So for this one, we're going to distribute the -3 term to each term inside the parentheses, the -x and the +4. I'm going to begin by distributing the -3 to the -x. A negative times a negative gives you a positive. 3 times x gives me 3x. Now I'm done distributing the -3 to the first term. I'm now going to distribute this -3 to the second term in the parentheses, the +4. A negative times a positive gives me a negative answer, and a 3 times 4 gives me 12. Now on a test, you might not see this answer looking like this, because in math, when the first term is positive, we usually don't write the sign and it's understood to be there. So on an exam, you'd more likely see the answer looking like this. Great. Let's look at something slightly more complicated. What if we take a monomial and we're distributing it over a polynomial, something with 2 or more terms? So in this case, we're going to distribute this -2x to every term inside the parentheses. So again, I'm going to draw an arrow each time I do one. I'm going to do -2x, times 5x to the third. So a negative times a positive is going to give me a negative answer. I'm going to multiply the coefficients. 2 times 5 is 10. And then I have to remember that the rule is when I'm multiplying that I add the exponents. So this is understood to be an x to the first power because, again, there is no exponent, so we know that it's 1 to the first power. So then if I'm taking x to the first times x to the third, I want to add these exponents. So 1 plus 3 is x to the fourth. Okay. Now I'm going to distribute this -2x to a +4x. A negative times a positive is a negative. Again, I'm going to multiply my coefficients. 2 times 4 is 8. And once again, I'm going to take x to the first times this is again an x to the first. So I'm going to add my exponents. 1 plus 1 is 2. And now I'm going to distribute this -2x to my final term, a -8. So a negative times a negative is going to give me a positive. 2 times 8 is 16. And I have nothing to multiply the x by, so it remains x. And that would be our answer. Now I'll show you one with a fraction. This one takes a little more scratch work, but it's just as simple as the others. So I'm going to distribute this -1/2 to all the terms inside the parentheses. So I have -1/2 times 8x squared. So I'm going to come over here and do scratch work on the side. If I have to multiply a fraction, this is -1/2, right? And I'm going to multiply it by 8x squared times 8x squared, okay? In order to make this x squared into a fraction, I'm going to put it over a 1. Then I just multiply my numerators. -1 times 8 is equal to -8x squared. And 2 times 1 is simply 2. My apologies. 2 divided by a -8 is -4x squared. Okay, so we're going to take this and make this our first term, -4x squared. Okay. Now we need to multiply this 1/2 by negative 12x. So again, I'm going to take this off to the side. I'm going to write negative 1/2 multiplied by negative 12x. Once again, to make 12x into a fraction, I simply put it over 1, and then I multiply my numerators. A negative times a negative is a positive. 1 times 12 is 12. X has nothing to multiply by. 2 times 1 is 2. And then I want to ask myself, can I divide this number by this number? And 2 divides evenly into 12, so I get 6x. And this is positive, so this is going to be my next term, positive 6x. Last, I need to multiply this negative 1/2 by a positive 10. Again, come on down here and do the scratch work, off to the side. Negative 1/2 times a positive 10. I'm going to make the 10 into a fraction, and then I'm going to multiply my numerator. A positive times a negative is a negative. 10 times 1 is 10. Positive 2 times positive 1 is a positive 2. 2 divided by negative 10 is a negative 5. And that will be my last term. So I'll take this, add it to my last one. Great. Now, last, I'm going to show you how to do a binomial times a binomial. In this case, we have to remember that we've got to distribute. We'll start with a simple one. Every term in this expression to every term in this one. And this is where those arrows can come in really handy. For example, I'm going to multiply this x by this x and by this negative 6. So to remember that, I'm going to put my first arrow as x times x, right? This is x to the first power times x to the first power. I add my exponents, I get x squared. Then I'm going to multiply this x by a negative 6. Okay, a positive times a negative is a negative. 6 times x is 6x. Now I'm going to multiply this second term, right, which is positive 4, by every term inside the other parentheses. So let's start by doing positive 4 times positive x. Positive times a positive is positive. 4 times x is 4x. Then I've got to multiply that 4, positive 4, by its second term in the other set of parentheses, which is a negative 6. Positive times a negative is negative. 6 times 4 is 24. I'm not quite done yet because I can actually bring a couple of these terms together. So we want to bring any like terms together, right? And we learned in addition and subtraction that they have to look exactly alike in order to bring them together. So if I look for any other x squared terms, I have no other x's that are squared. So this cannot be combined with anything else. I have a negative 6x and I have a positive 4x. They're both x to the first power, so they can come together. And then lastly, I have a negative 24. There's no other constants, numbers without variables, so I can't bring that together with anything else. It will just have to remain alone. Okay, then I'll bring all my work down. There's nothing to combine x squared with. I have this negative 6x and a positive 4x, different signs, so I know I want to subtract the coefficients. 6 minus 4 is 2. Keep the sign of the larger. 6 is larger than 4. It's negative, so it's a negative 2x. And then minus 24 stays the same. I hope this video is helpful. Feel free to rewind and look at any of the material again.